fluid flow has a velocity equation, vector v equal to -811, plus 4j. If at time t equal to 1, the fluid particle is at point 12, draw the path line of the fluid particle. Okay, here is the fluid flow. Inside this pipe, fluid particles are flowing. Well, the trace of the path taken by this particle is a path line. Assume the velocity of the particle is a vector v equal to ui plus vj plus wk. Well, the velocity component on the x-axis, u is dx dt. In the same way, v is dy dt, and w is dz dt. Knowing the values of u, v, and w, we can calculate x, y, and z, which are none other than the position of the fluid particle at a certain time. The first step is identification. The velocity component on the x-axis, u is equal to -8x. The velocity component on the y-axis, v is equal to 4. At time t is equal to 0, the particle's position, x0 is equal to 1, and y0 is equal to 2. Now, we can calculate the path line. The position of the abscissa at a certain time can be calculated through the velocity component u. Plugging in the value of u, dx dt is equal to -8x. Using the separation technique, dx over x is equal to -8 dt. Integrate both sides. The integral of 1 over x with respect to x is ln x. The integral of 1 with respect to t is t. Ln x is equal to -8t plus c. To get the value of c, we can use the limit value. Ln x0 is equal to -8t0 plus c. Ln 1 is equal to -8 times 0, plus c. Then c is equal to ln 1. Isn't ln 1 equal to 0? So the position of the abscissa, ln x is equal to -8t. Meanwhile, the position of the ordinate at a certain time can be calculated through the velocity component v. dy dt equals v. Plugging in the value of v, dy dt equals 4. Simplifying this equation, dy is equal to 4 dt. Integrate both sides. The integral of 1 with respect to y is y. The integral of 1 with respect to t is t. Y equals 4t plus c. To get the value of c, we can use the boundary values. Y0 equals 4t plus c. 2 equals 4 times 0 plus c. C equals 2. So the position of the ordinate is 4 equals 4t plus 2. These are the coordinates of the particle. Ln x equals -8t, and y equals 4t plus 2. Now, to plot this position on the coordinate plane, we can relate these two equations by eliminating the value of t. We can use the value of t from the equation for y. T equals y minus 2 over 4. Next, substitute the value of t into the equation for x. Ln x is equal to -8 times y minus 2 over 4. Ln x is equal to 4 minus 2y. Simplifying it, y is equal to 2 minus half of lane x. Here is a sketch of the path traveled by the particle. If this curve is combined with the streamline curve, then the two curves will coincide. Yup, hopefully useful, and don't forget to watch the next video.
I like to be educated, but I'm so frustrated.